Okay, so dinosaurs, right? They've been on our planet for over 165 million years, and throughout that time they have evolved to fill just about every ecological role imaginable. From small feathered ancestors of birds to enormous long-necked sauropod. It seems like they would have been incredibly difficult to wipe out. And yet we know that at the end of the Cretaceous period around 66 million years ago, they did get wiped out along with around 75% of all species on Earth. So how did it happen? Well, it wasn't your grandpa's pet asteroid. This was one big space rock, and it changed our planet forever. But before we get into the details of this colossal cosmic collision, first we have to talk about the dinosaurs' long road to world domination. Dinosaurs first appeared during the Triassic period around 230 million years ago. But for the first 45 million years or so, they were relatively small and relatively unknown. They didn't become the dominant species on land until the Jurassic period, when large herbivorous sauropods like Diplodocus took over and terrifying predators like Allosaurus kept the other large animals in check. This set the stage for dinosaur domination for the next 80 million years. And then toward the end of the Cretaceous period, around 66 million years ago, an asteroid or possibly a comet hurtled toward Earth and crashed into the shallow waters off the coast of Mexico's Yucatan Peninsula. Today, this site is known as the Chicxulub crater, and it's about 180 kilometers wide. That's roughly the size of the city of Philadelphia. But when it was first discovered in 1978, scientists weren't sure if it really was an impact crater. It was until they found shocked quartz and tektite deposits at the site that they confirmed its extraterrestrial origin. But even after they realized that the crater was caused by an asteroid, scientists debated whether that asteroid was really responsible for the mass extinction at the end of the Cretaceous. Some thought that maybe there were multiple factors at play, or that perhaps the asteroid struck the Earth at a time when dinosaurs were already on their way out. After all, evidence shows that there had been some dramatic changes in the environment leading up to the asteroid impact. For example, the Deccan Traps in India, a massive igneous rock formation, began spewing lava around 66 million years ago. And these lava flows released huge amounts of greenhouse gases and other pollutants into the atmosphere. Then there were the mammals. Evidence suggests that a group of mammals that lived in what is now North America went extinct right around the same time that the asteroid hit, but not in the same layer of rock. This made some scientists think that maybe the asteroid was solely responsible for the mass extinction, because if it was, you'd expect to find the mammal fossils in that same rock layer. But now we think the mammals went extinct because of the asteroid. Thanks to a study published in 2020, by analyzing the mammal fossils, researchers determined that the mammals died out right before the asteroid hit, which means that they probably died as a result of the environmental changes brought on by the lava in India. So while there may have been a few factors at play, it looks like the asteroid was definitely one of them. So let's revisit the asteroid impact itself. In addition to the crater in Mexico, there are rock layers all around the world that contain an unusually high concentration of iridium, which is an element that's rare on Earth but common in space rocks. These iridium-rich layers are called ejecta blankets, and they form when an asteroid strikes the Earth, and the ejecta is matter thrown up into the atmosphere during the impact. In the case of the Chicxulub asteroid, ejecta was blasted hundreds of kilometers into the sky. Over time, this material spread across the globe and settled out on what are now several continents. This layer of rock is particularly well preserved in the Gubbio region of Italy, and it is here where scientists confirmed that the asteroid impact happened right around the time that the dinosaurs died out. But exactly how did this asteroid cause such devastation? We can start by looking at the immediate effects. Even though the asteroid was around 6 miles wide, most of the rock vaporized almost instantly upon entering the atmosphere, and as it flew through the air, it left behind a bright white cloud of pulverized rock, dust, and sulfur compounds. In fact, the asteroid was so big that this cloud stretched all the way around the globe, and as it circled the planet, it blocked out the sun and plunged Earth into darkness. Just to put this in perspective, the asteroid was about 1,000 times wider than the 2013 Chelyabinsk meteor that exploded over Russia, and the energy it unleashed was around 60,000 times greater than the energy of the atomic bomb dropped on Hiroshima. To say that this asteroid was an extinction-level event is kind of an understatement. But before we go any further, we should probably define what we mean by mass extinction. In a mass extinction, at least 75% of all species disappear from the fossil record within a relatively short amount of time. But exactly how short is a mass extinction short? Well, based on the geologic timescale, the end of the Cretaceous, along with 4 other major extinction events, are separated by orange lines, which indicate a change on the order of millions of years. But in reality, the changes happen much faster than that. For example, at the end of the Devonian period around 359 million years ago, the mass extinction only took about 200,000 years to unfold. And the end of the Permian, often called the Great Dying, saw the extinction of more than 90% of marine species and 70% of terrestrial vertebrates, and it's believed to have taken about 60,000 years to run its course. So even though the end of the Cretaceous lasted for hundreds of thousands of years, we can assume that the effects of the asteroid impact were felt within a much shorter span of time. and the impact itself would have triggered climate change on a global scale. When the asteroid struck, it plowed through the shallow water off the coast of Mexico at a speed of around 43 kilometers per second. In an instant, it displaced an estimated 1.6 trillion cubic meters of rock and water. This created a towering wall of water that raced away from the epicenter of the impact in all directions. Now, as the wave approached the shore, it would have looked like a gigantic tsunami, but as it moved out into the open ocean, it would have broken apart into smaller waves that spread out across the entire globe. Then there was the heat. The impact itself generated temperatures as high as 3,000 degrees Celsius, and as the hot debris shot skyward, it rained down on the surrounding area, setting forests on fire. Hot rocks also rained down on the coastlines, killing off many marine organisms, and the intense heat even caused widespread wildfires on land. Meanwhile, the dust in the atmosphere reflected and scattered sunlight, creating a hazy sky and plunging the planet into darkness. As weeks turned into months, this material spread around the world and blocked out the sun. Even during the day, it was as dark as the middle of the night, and plants couldn't photosynthesize, so they began to die. As the plants died, so did the animals that ate them. Then came the acid rain. The sulfur compounds that had been blasted into the atmosphere combined with water, creating a weak sulfuric acid. And as this acid fell to the ground in the form of rain, snow, or hail, it killed off even more life. Marine organisms with calcium carbonate shells or skeletons, like corals and foraminifera, were especially vulnerable. In fact, the fossil record shows that nearly all of the planktonic foraminifera in the ocean disappeared after the asteroid impact. Still, some creatures managed to survive, including birds, small mammals, and a few species of reptiles. As for the dinosaurs, well, we don't know for sure, but since their relatives today are mostly birds, it seems likely that at least some of them survived. In the end, the asteroid impact triggered an abrupt and dramatic change in Earth's geology, climate, and ecosystems. Within a few thousand years, the composition of the atmosphere and the chemistry of the oceans changed dramatically, and within a few 100,000 years, the planet looked very different than it does today. But in the grand scheme of things, the asteroid impact actually helped pave the way for the rise of mammals. Before the asteroid, mammals were mostly small proto-wombats that scurried around the forest floor. But after the asteroid, they were free to roam wherever they wanted, because there were no longer any large predatory dinosaurs around to eat them. Plus, the flowering plants, which had been around since the early Cretaceous, took off after the mass extinction, and these plants provided new food sources and habitats for mammals to exploit. And thus, the mammalian radiation began, which eventually led to the appearance of giant sloths, saber-toothed cats, and yes, even our ape-like ancestors. So while the asteroid that killed the dinosaurs was obviously bad news for the dinosaurs, it ended up being pretty great news for us. For more dramatic tales of extinction, stay tuned. And remember, don't be sorry, just be kind.